Hey guys, this is Subhashish Mishra. Today we are starting a new series for the Python interview questions and answers. We'll see different types of interview questions. So let's see the very first interview question. What is Python? What are the benefits of using Python? So Python is an interpreted, object-oriented, high-level programming language with dynamic semantics. It was created in late 1980s by Guido van Rossum and first released in 1991 as Python 0.9.0 version. Python is widely used for web development, scientific computing, data analysis, artificial intelligence and many other applications. There are a lot of benefits using Python. So let's see all of them. So the very first thing is Python is simple and easy to use. Python is a high level programming language that is easy to use, read, write and learn. Python syntaxes are easy to learn. Then Python is an interpreted language. Since Python is an interpreted language, it executes the code line by line and stops if an error occurs in any line. Python only shows one error even if the program has multiple errors. It makes easier debugging and code development. Then we have dynamically typed. The developer doesn't assign data types to variables at the time of coding. It automatically gets assigned during execution. That is your dynamically typed. Python is free, open source and Python has a large active community base. So this is a again major benefit as Python is free, it is open source and it has a large active community. So that contributes to its development and provides support. Extensive support for libraries. Python has vast libraries that contains almost any function needed. It also further provides the facility to import other packages using Python package manager or Peep. Then portability. Python programs can run on any platform without running any change. It only needs to be written once and then it can be run anywhere. Then Python has user friendly data structures. Python offers intuitive and easy to use data structures, simplifying the data manipulation and management. Python is object oriented and procedural programming language. It supports both object oriented and procedural programming, providing the versatility in coding styles. Let's move to the next question. How is Python an interpreted language? Python is one of the most popular interpreted language. What interpreted means? Interpreted means running code line by line. It also means that the instructions is executed without earlier compiling the whole program into the machine language. When it encounters an error, it stops the execution and reports the problem. Python only shows one error even if the program has multiple errors. This makes debugging easier in Python. Python doesn't need a separate compilation step like we have in C++ and Java. You can write your Python code and run it directly. This makes Python fast to develop. Now let's discuss it with an example. Consider a scenario where you are trying to run a Python code, but unfortunately you have made some mistakes at the bottom of the code. You will find that there is an error generated for obvious reasons, but along with the error you will find the output of the program till the line of the program is correct. So this is possible because Python reads the code line by line and generates output based on the code. You can try it on your own, you can write some print statement and try to execute. You can easily get to know Python is an interpreted language and it executes line by line. So, wherever there is a error, it will stop the execution, but if there is no error or till the line where is no error, it will work fine. It will print all those lines. You can try it on your own. One more thing I would like to tell you guys, in most of the books you will find that Python is an interpreted language, but the hidden fact is Python is both compiled as well as an interpreted language. That means when we run a Python code, it is first compiled and then interpreted line by line. The compilation part is mostly hidden from the user. While running the code, Python generates a bytecode internally. This bytecode is then converted using Python virtual machine to generate the output. Let us move to the next question. Can you explain namespaces in Python? So, a namespace is a system that has a unique name for each and every object in Python. Variables and methods are examples of objects in Python. Namespaces is a collection of the known symbolic names and the details about the thing that each name refers to. A name can be thought of as a key in a dictionary and object are the values in a namespace. Let us take a real time example. The role of a namespace is like a surname. One might not find a single Subhasis in the company, there might be multiple Subhasis, but when you particularly ask for Subhasis Mishra or Subhasis Reddy with your surname, then there may be only one. On a similar note, the Python interpreter understands what exact method or variable one is trying to point in the code depending upon the namespace. So, the division of the word namespace gives a little more information, like name means a unique identifier, space means talks something related to a scope. So, here a name might be of any Python method or variable and space depends upon the location from where it is trying to access a variable or method. In Python, there are 4 types of namespaces. One is built-in, then global, then local, then enclosing. As its name suggests, it contains predefined names of all Python's built-in objects already available in Python. You can list these names with the command dir built-in. You can just go to your Python terminal and just type this command, then you can get it very easily. Then we have global namespace. The global namespace consists of any names in Python at any level of the main program. It is created when the main body executes and remains in existence until the interpreter terminates. One more thing, this may not be the only global namespace that exists. The Python interpreter creates a global namespace for any module that our Python loads with the import statement. Then we have local namespaces. Local namespaces are at the local or inner function level. A local namespace is specific to a function or a method. It is created when a function is called and only lasts until the function returns. Then we have enclosing namespaces. These enclosing namespaces are at the higher level or outer functions. Enclosed namespaces are similar to the local namespaces, but nested functions create them. Here the nested means when you have functions defined inside other functions. The inner function can access variables from its own namespace as well as variables from the other functions namespace. We will move to the next question. What are the common built-in data types in Python? Data types specify the type of data that can be stored inside a variable. For example, number equal to 10. So, here 10 is an integer value, right. So, basically 10 is assigned to the number variable. So, the data type of number is the integer class. So, there are different data types in Python. So, the very first one is numeric data type, which is used to hold numeric values. Again, there are 3 types in numeric data type: int, float and complex. So, integers like int, it contains positive or negative whole numbers, without fractions or decimals. In Python, there is no limit to how long an integer value can be. This value is represented by int class. Then we have float. So, float holds floating decimal points and it is accurate up to 15 decimal places. This value is represented by float class. Then we have complex. It holds complex numbers. It is specified as real part plus imaginary part j, which in the example you can see 1 plus 2j, 1 is the real part, 2 is the imaginary part. Okay. So, a complex number is represented by a complex class. Then we have dictionary. A dictionary is a key value pair set arranged in any order. Here the keys are unique identifiers that are associated with each value. Each key value pair in a dictionary is separated by a colon, where each key is separated by a comma. So, dictionary you can see the example I have given 1 colon Python, 2 colon Java, 3 colon PHP. So, 1 is the key, Python is the value, 2 is the key, Java is the value, 3 is the key, PHP is the value. Okay. Then we have boolean. So, there are two boolean values, true and false. We all know about it, the boolean. Then we have set. Set is an unordered collection of unique items. Set is defined by values separated by commas inside the curly braces. So, here you can see the example id equal to 1001, 1002, 1003 and so on. Okay. Then we have string. String is a sequence of characters represented by the either single or double quotes. For example, name equal to Python or n equal to py, here I have given, right. So, that is the example of a string. Then we have list. List is an ordered collection of a similar or different types of items separated by commas and enclosed within the bracket. So, here you can see example of list equal to 5, Python 2.4. So, basically it can contain similar or different data types. So, here you can see different data types, right. 5 is integer type, Python is a string, 2.4 is float. Okay. So, list is an ordered collection of similar or different types of items. Then we have tuple. Tuple is an ordered sequence of items same as a list. The only difference is that tuples are immutable, means tuples are, once tuple is created it cannot be modified. In Python we use the parenthesis to store items in the tuple. So, here in the example you can see tup equal to hello Python 2. Okay. So, this is similar to list, but only thing is in the list you can see this is the bracket and here the bracket is like this. Okay. We will move to the next question. What is slicing in Python? Slicing is the process of accessing a subsequence of a sequence by specifying a starting and ending index. So, here when I am telling about sequences, the different sequences like list, tuples, strings. Okay. So, in Python we perform slicing using the colon operator. The syntax for slicing you can see here, start index colon end index colon step. You can omit this step. So, it is kind of optional. So, if you want to write start index colon end index, that means start index is the index of the first element in the subsequence and end index is the index of the last element in the subsequence, but you need to exclude the last or the last value, whatever is the last index, basically end index. Okay. So, here you can see the example I have given. If you want to, if you have a list like Python, Java, C and PHP and you want to do the slicing, you can just print list 1 colon 3. So, basically you are doing the slicing using the colon operator, right. So, here you can see the output as Java and C, because it is the slicing is happening and after slicing we are getting this value 1 colon 3. Okay. We will move to the next question. What are the keywords in Python? Python keywords are special reserved words that have specific meanings and purposes, and these keywords cannot be used for anything else. can be used for only those specific purposes. These keywords are always available, you will never have to import them into your code. Python keywords are different from Python built-in functions and types. The built-in functions and types are always available, but there are not much restriction in their usage like keywords. Keywords are used to define the syntax of the coding. Keywords cannot be used as a variable name, function name or any other identifier. All the keywords in Python are written in lowercase except true, false and none. There are 35 keywords in Python 3.11. So, here I have listed all of them, you can have a watch. Okay. There are 35 different keywords. Okay. So, that is all about your keywords in Python. We will move to the next question. What are the literals in Python, and explain about different literals. Literals are representations of fixed values in a program. They can be numbers, characters or strings like that, right. For example, hello world, it is a string, 12, it is a number, 23.0, it is a float value, like that. So, literals are often used to assign values to variables or constants. For example, name equal to Subhasis. So, here name is the variable and Subhasis is the literal. There are different types of literals, 6 different types of literals, right. Numeric literal, Boolean literal, string literal, character literal, special literal, then literal collections. So, first we have numeric literals. Numeric literals are immutable, means unchangeable. Numeric literals can belong to 3 different numerical types, that is integer, float, complex. Okay. So, for example, we will take integer, that is number equal to 50, it is an integer. Then we have Boolean literals. There are 2 Boolean literals, true and false. So, you can give an example like result equal to true or result equal to false. Then string literals. A string literal is created by assigning some text enclosed in a single or double quotes to a variable. Example, name equal to Subhasis. So, this is a string. Okay. So, Subhasis is a string literal assigned to name variable. Okay. Character literal, it is created by assigning a single character enclosed in a double quote. Here you can see example A equal to T. So, here T is a character literal assigned to A. Then special literal, Python contains one special literal, none. Okay. So, we use it to specify a null variable. So, here you can see the example value equal to none. Okay. Then we have literal collections. There are 4 different literal collections: list literals, tuple literals, dictionary literals and set literals. Okay. So, in the list literal you can see the example. So, city equal to Bangalore, Mumbai, Delhi. So, different type of values. Similarly, in the tuple we have numbers equal to 1, 2, 3. Dictionary, it is key value pair A, then apple, B for ball, C for cat. In the set literal, okay, with the unique values A, E, I, O, U, these are the vowels. Okay. So, these are the different literals present in the Python. Okay. We will move to the next question. What is Python path? Python path is an environment variable that specifies a list of directories to search for Python modules when importing them. When you import a module in Python, Python looks for the module in the directories specified in sys.path, which is a list of directories that includes the current working directory and directory specified in Python path. Python path is an environment variable which you can set to add additional directories where Python will look for modules and packages. For most installations, you should not set these variables since they are not needed for Python to run. Python knows where to find its standard library. The only reason to set Python path is to maintain directories of custom Python libraries that you do not want to install in the global default location. So, here you can see one example how you can set it the Python path in your Mac. Okay, export Python path equal to the path. Okay. So, that is all about your Python path. We will move to the next question. What are the decorators in Python? A decorator is a function that allows us to modify the functionality of a function by wrapping it in another function. The outer function is called the decorator, which takes the original function as an argument and returns a modified version of it. So, basically a decorator is a function and it takes another function as argument and returns a function. So, here you can see an example. So, here we have a decorator. So, the name is decorator underscore EG. Okay. It is taking a function as argument. Okay. And inside this decorator we have another function, that is wrapper function. Okay. Wrapper underscore EG. And what we are doing inside this wrapper underscore EG function, we are just printing. We have two print statements, one is before test, then we have the actual function which we are calling. Okay. This is the actual function what we have passed here. Then again we have print after test. Okay. Then we are returning wrapper underscore EG, because we are telling a decorator will always take a function as argument and returns a function. So, here you can see function as argument and returns a function. Okay. Then this is the actual test. Okay. Where we are this is the actual test, this is the perform underscore test. Here we are printing the executed the actual test. This is the message we are printing here, and here we are calling the decorator h1 equal to decorator EG, then perform test. Okay. Perform test is nothing but this test, and this is the argument, right? In place of function we are calling it. Okay. Then what will be the output for this? Let me know in the comment section. What do you think? What will be the output? Okay. So, the output will be, first it will come as before test, then this one executed the actual test because the function is here, then after test. That will be your output. Okay. So, this is one type how you can define your decorator. There is another way also. Decorators generally are defined before the function they are enhancing. To apply a decorator, we first define the decorator function, then we write the function it is applied to and simply add the decorator function above the function it has to be applied to. So, how it will happen? It will happen using @ symbol before the decorator. So, here is the example you can see, right. See the same thing, whatever happening here we are doing also the same thing. First is the decorator function, okay, but to use it we are not calling something like this, right, h1, this one we are not doing, we are just using this decorator, okay, @ decorator, the decorator name we are giving before the actual function. Okay, perform test, this is what we want to decorate, right. On top of that we are giving this decorator. Okay, this will also give the same output before test, then it will give executed the actual test, then the after test. You can also practice on your own and you can see, and you can let me know in the comment section what is the output you are getting. Okay, we will move to the next question. What are Python modules? Name some commonly used built-in modules in Python. Python module is a file that contains Python code to perform a specific task. A module may contain variable, functions, classes, etc. So, basically a Python module is a .py file containing executable code. To answer why we use modules, when our program grows bigger, it may contain many lines of code. Instead of putting everything into a single file, we can use modules to separate codes in separate files as per their functionality. This makes our code organized and easier to maintain. So, if I will show you one example. So, here we have calculation.py file. Okay. Inside that we have two methods, one is add and then is subtract. Basically, we have two functions. Okay. Then what we are doing? We are importing this calc.py. So, import calc, import calc we are doing. This is the file name, that is what we are importing, and after importing we can use the method, okay, calc.add, whatever method we have given here. There are two arguments, x and y, right? That is what we are passing here. Let me know what is the output we will get here. Okay, let me know in the comment section what will be the output here we will get. Some of the commonly used built-in modules like OS. So, this module provides a unified interface to a number of operating system functions. GC, this module provides an interface to the built-in garbage collector. Math, this module implements a number of mathematical operations. Random, it generates pseudo random numbers. Date and time, this module provides functions to deal with date and the time within a day. JSON, it encode and decode the JSON format. So, here you can see one example, import math, then it is printing square root of 100, math dot square root function. Okay. So, these are the built-in methods. Okay. So, let me know in the comment section what will be the output for this particular one, import math and this. Okay, let me know in the comment section. We will move to the next question. What are the local variables and global variables in Python? When we declare variables inside a function, these variables will have a local scope within the function. We cannot access them outside the function. These type of variables are called local variables. For example, here you can see, right, I have a function find value, okay, and here inside this find value function there is a local variable, and what is the value for that? I have taken LV equal to 50 and we are printing local value LV. Then we have this find value function, and what we are doing? We are trying to access here the local variable. We are trying to access the local variable outside the find value function. So, what will be the output? The output will be, for this it will print LV value equal to 50, but for this line there will be error, name LV is not defined, because local variable you cannot access outside the function, that is why. Okay. So, what is global variable? In Python, a variable declared outside of the function or in global scope is known as a global variable. This means that global variable can be accessed inside or outside the function. Let us see with the same example. So, here we have taken a global variable. Here it was local because it was defined inside the function. Here it is not inside any function. So, that is why it is a global variable. And then we have this find value method, okay, and here we are printing the local variable, and here outside the find value function we are printing the global value, okay, and see in both the places the value is 50/50 because it is a global variable. Okay. So, variables declared outside a function or in a global space are called global variables. Okay. So, that is the major difference between your local variable and global variable. We will move to the next question. What is type conversion in Python? Type conversion is the process of converting data of one type to another. For example, converting int data to a string data, basically int data type to string data type. There are two types of conversion. One is implicit type conversion, which is known as automatic conversion, and then explicit type of conversion, which is known as manual conversion. So, what is Python implicit type conversion? In certain situation, Python interpreter automatically converts one data type to another. That is known as implicit type conversion. Let us see with an example. So, here we have taken two variables. One is A of data type integer and then another one is B of data type float, and we have added them and then stored in another variable, that is sum. Then what we are doing? Then we are checking the data type of the sum variable, and here we see that the data type of sum variable is float. So, how it happened? It had been automatically converted into the float data type by the Python compiler, and this is called implicit type conversion. The reason that the sum variable was converted into the float data type and not the integer data type is that if the compiler had converted it into the integer data type, then it would have to remove the fractional part, which would have resulted in data loss. So Python always converts similar data type into larger data type to prevent the loss of data. That is your implicit type conversion. That is why it is called automatic type conversion. Then we will see what is explicit type conversion in Python. In explicit type conversion, user changes the data type of an object to the required data type manually. Built-in functions like int, float, string, all are used to perform explicit type conversion. So explicit type conversion is also called typecasting, because the user casts or changes the data type of the objects. With explicit type conversion, there is a risk of data loss, as user is forcing an expression to be changed in some specific data type. We will see it with an example. Here we have two variables. A is of the number data type and B is of string data type. Then we are adding these two and storing the value in result1 variable. But while adding, we see a type error occurs. Then how we will do it? In this case, we have to use explicit typecasting. So to do that, here you see we are converting the variable B into an integer type and then adding variables A and B, and then storing the sum in result 2 and then printing it. And now we see the result is 300. So here we explicitly or manually converted string to integer using built-in method int. So in order to perform this operation, we have to use explicit typecasting. So here in this code, we have converted the variable B into int type and then added variable A and B, and the sum is stored into the variable named as result2, and when we printed, it displays 300 as output. There are many inbuilt functions that you can see here: int, float, ord, hex, oct, tuple, set, list, dictionary, string. So all these things you can see it here. Okay, so that's all about your type conversion in Python. We'll move to the next question. Is indentation required in Python? Indentation is necessary for Python. It specifies a block of code. In other popular languages like C and Java, we use curly braces or brackets to define a block of code, but in Python we use indentation. All code within loops, classes, functions, etc. is specified within an indented block. It is usually done using 4 space characters. To indent in Python, white spaces are preferred over tabs. The best practice is to use 4 white spaces for the first indentation and then keep adding additional 4 white spaces to increase the indentation. If your code is not indented properly, it will not execute accurately and it will throw some error. So here in this block of code, you can see the first level of indentation is start from foo method, okay, and below to that you can see the print statement, okay. Then again the second level of indentation you can see in our if else block, okay. So this is how we give indentation in Python, and it is very required in Python. We'll move to the next question. What is a dictionary in Python? The dictionary is an unordered collection that contains key and value pair separated by commas inside curly braces. Dictionaries are optimized to retrieve values when the key is known. The same key cannot appear more than once in a dictionary. If the key appears more than once, then only the last value will be retained. The value can be of any data type. One value can be assigned to more than one key. So here you can see one example, capital, okay, and here we have the key value pair, like for Karnataka, Karnataka is the key and value is Bangalore. Odisha is the key and the value is Bhubaneswar. Rajasthan is the key and Jaipur is the value. So basically the key value pair. Okay, and here we are printing the type of capital, and that you can see it is of dictionary type. Okay, you can also use a number, string or tuple as a key, but you cannot use list as a key in dictionary. Very, very important. You can use number, string or tuple as a key, but you cannot use a list as a key in a dictionary. But you can use list as a value in dictionary. You can use list as a value in the dictionary. Okay, we will move to the next question. What is the difference between Python arrays and lists? A list in Python is an inbuilt collection of items that can contain elements of multiple data types, which may be either numeric or characterological values, etc. List are the inbuilt data structure of Python. List is an ordered collection supporting negative indexing. A list can be created using open brackets containing data values. Contents of list can be easily merged and copied using Python inbuilt functions. Here you see one example of list. Okay, so we have a sample list, and then we are printing the type and what is the list contents, right, printing that particular list. So here you can see the details. Then we have array. What is an array? An array is a data structure that holds fixed number of elements, and these elements should be homogeneous. What is homogeneous means? Homogeneous means have the same data type. So the array will contain same data type. In the list it can contain different kind of data types, but array will contain similar type of data. Arrays are not the inbuilt data structures readily available in Python. You must import the array from the array or numpy module. It is also square bracketed, mutable and ordered. So here you see an example. Okay, we have to import array. Okay, that's what I told. You have to either import from array or numpy. Here we are importing from array. Okay, and then we have to write array dot array, and that's what we are writing here. Okay, so that is the major difference between array and list. List can contain elements of multiple data types, but array will contain only similar data type. Okay, and array is in fixed in size, and arrays are not the inbuilt data structure, where list is the inbuilt collection. Okay, so let's move to the next question. What is the purpose of init function in Python? The init function is called every time an object is created from a class. The init method lets the class initialize the object's attributes and serves no other purpose. It is only used within the class. The init method in Python is equivalent to the constructor concept in C++. And you know, constructors are used to initialize the object state. So here I have given an example. So we see here we have a class, that is car class, and then we have used the keyword def to define a function or method, that is init method. Okay, and the init method initializes two attributes, that is brand and color. Then we have created an object as C from car class, and we pass the arguments Maruti and white, okay, which corresponds to the respective parameter of the init method of the class car. The init method uses the keyword self to assign the values passed as arguments to the object attributes self.brand and self.color. We have also one more method, that is car details. Okay, there we are just printing car brand and car color. Okay, and how we are accessing that? We are accessing using the object, that is C. That's why we are writing C dot car details. Then what we will get as an output? Here we will get an output as car brand as Maruti and car color as white. So this is how the init function is used. Okay, basically the init function is called when an object is created. Okay, we will move to the next question. What is self in Python? Self is an instance or an object of a class. With self keyword, we can access the attributes and methods of the class. Self keyword helps to differentiate between the methods and attributes of a class with local variables. The self variable in the init method refers to the newly created object, while in the other methods it refers to the object whose method was called. In Python, whenever we define a method for a class, we use self as the first parameter. Let's see with an example. So here all the methods including init method have the first parameter as self. We know the class is a blueprint of the object. So this blueprint can be used to create multiple number of objects. And here we have different objects, like the class is dog, but objects are dog1 and dog2. The self keyword is used to represent an instance of the dog class. So the two dog objects dog1 and dog2 have their own name and age attributes. If there is no self argument, the same class couldn't hold the information for both the objects. Since the class is just a blueprint, self allows access to the attributes and methods of each object, and this allows each object to have its own attributes and methods. So even long before creating these objects, we reference the objects as self while defining the class. So that's all about self in Python. Okay, we'll move to the next question. What is Peep software in the Python world? Peep stands for Python Installer Package, which provides a seamless interface to install the various Python modules. Peep is a command line tool that searches for packages over the internet and installs them without any user interaction. So here you can see few Peep commands. Okay, so if you will give Peep ---- version, it will give you which Peep version is installed in your system. Similarly, if you will give Peep install camel case, it will install camel case in your system through Peep command. Okay. Similarly, if you want to install something else, so you can give Peep install xyz. If you want to uninstall that one, you can give Peep uninstall xyz. Like whatever you want to install or uninstall, you can use this command. Then you have Peep list. So basically, it will list all the packages which you have installed through Peep. Okay. So that's the usage of Peep. Okay. We'll move to the next question. What are the doc strings in Python? Python documentation strings or doc strings provide a convenient way of associating documentation with Python modules, functions, classes and methods. Doc strings are used to document the code. It describes what exactly the function will do. Doc strings are like comments only. The doc strings are declared using triple single quotes or triple double quotes. So here you see one example. Okay, here what we are doing, here we have given a doc string comment, right? So you can see here I have given it with triple double quotes. Okay, and then we are doing some operation, but whatever we are doing here, that we have written inside this triple double quotes. So basically you will able to understand with these lines what the code is doing. Okay, here we are adding two numbers. Okay, that's what we have written. This code adds two numbers. Okay, we'll move to the next question. What is the usage of help function and dir function in Python? So help and dir function are accessible from the Python interpreter and used for viewing a consolidated dump of built-in functions. Basically, the help function is used to display the documentation string and also facilitates you to see the help related to modules, keywords, attributes and all. So here you see, if we will just write help and this print function, you can see all these details. Okay. Then what about this dir function? This dir function is an inbuilt function in Python 3 which is used to display properties and methods of object passed as an argument. Here object can be any function, modules, strings, list and all, right. So, here you see I have a list my underscore list, and then what I am doing is inside print, inside the dir method I am passing this my list as a argument, okay, and then I can see what are the inbuilt functions available for that, okay. You can see this add, class, all these things, right, till reverse and sort. So, that is the usage of your dir function, okay. We will move to the next question. What is the difference between range and xrange? So, Python range and xrange functions are used to generate a list of integers within the given range. These two inbuilt functions are mainly used while dealing with loops, conditional statements and all, where you have to loop or iterate through a list of integers or characters. So, here you see I have given the exact difference between range and xrange function in Python. The range function returns a list of integers, whereas xrange functions returns a generator object. Then range function takes more memory as it keeps the entire list of elements in memory, whereas in xrange it takes less memory as it keeps only one element at a time in memory. Range function consumes more memory than xrange function. Then what is the reason behind it? Range function returns a list, while the xrange function returns an objects. That is why range functions consumes more memory than xrange function, okay. Then we will move to the next point. All arithmetic operations can be performed as it returns a list. Such operations cannot be performed on xrange. What that means? So, as we know, the range function returns a list of integers. So, all the basic operations like addition, subtraction, multiplication can be performed on range function, but we cannot perform these operations on xrange function as the return type is object, okay. Then range function's execution speed is slower, whereas xrange execution speed is faster. The xrange function is faster in implementation than range function, as the xrange function evaluates the generator object only when required and not when the generator function is created, okay. Then we will move to the next point. In Python 3 xrange function is not supported, whereas in Python 2 xrange function is used to iterate in for loops. So, in Python 2.x there are two functions available to generate list of integers, that is your range function and xrange function, but there is no xrange function in Python 3. It is only range function in Python 3. It is because the range function in Python 3 is just a re-implementation of xrange function of Python 2. It actually works the same way as xrange works, okay. So, that is the major difference between your range function and xrange function. We will move to the next question. How does lambda function differ from a normal function in Python? Python lambda functions are anonymous functions, which means that the function is without a name. The def keyword is used to define a normal function in Python. Similarly, the lambda keyword is used to define an anonymous function in Python. Lambda function can have any number of parameters, but can have just one statement. Lambda is similar to the inline function in C programming. It returns a function object. In case of normal function, you can define a function name, pass the parameter and mandatorily have a return statement. But in lambda function, it is typically used for simple operations without the use of function names. It can be also used in place of a variable. So, here I have given two examples. The left side one, here you see this is the normal function which we have used using the keyword def, okay. So, we are finding the cube here, def cube, then we are passing the argument as y and then returning the y into y because we are finding the cube, then we are printing. Here we are printing normal function then cube. See, the result here is 1000. But in case of lambda function, what we are doing, this lambda underscore cube is nothing but a variable and then we are assigning this lambda function details, right. So, lambda y colon y into y into y. This is how you can write the lambda function using the lambda keyword. Then finally we are printing it, and then again here we are passing the argument as 10 and we are getting the output as 1000. Okay. So now you understood what is the difference between a lambda function and a normal function. We will move to the next question. What is exception handling in Python? An exception is an error which happens at the time of execution of a program. Whenever there is an error in a program, exceptions are raised. If these exceptions are not handled, it drives the program into a halt state. Exception handling in Python is required to prevent the program from terminating unexpectedly. Here you can see the list of default Python exceptions. Okay. So the very first one you can see the assertion error. What assertion error means? It raised when the assert statement fails. Similarly, tab error. It raised when the indentions consist of inconsistent tabs or spaces. Name error raised when a variable is not found in the local or global scope. You can read it. Okay. Zero division error raised when you divide a value or variable with 0. Syntax error raised by the parser when the Python syntax is wrong. System error raised when the interpreter detects an internal error. Okay, so these are the different errors. Okay, so we'll move to the next question. What is fixture and yield? Fixtures are functions which gets executed before each test function to which it is applied. Fixtures are used to feed some data to the tests such as database connections, URLs to test, and some sort of input data. Therefore, instead of running the same code for every test, we can attach fixture function to the test and it will run and return the data to the test before executing each test. So, let us understand it with an example. Let us say we have 10 test cases, and before starting each test case we need to connect to the database, and after execution of the test cases we need to close the database connection. Or let us say if you are executing UI test and before each test we need to open a browser, and after the test execution we need to close the browser. So, in this case you should not write same repetitive code for connecting to database and closing the database connection. We should write it inside a fixture and same should get executed for each test. Then what is yield? Any tear down code for a fixture is placed after the yield statement. Basically, yield fixtures is used to perform setup and tear down operations. Yield fixtures use the yield keyword to define the setup and tear down operations. So, I will show you one example, then you will able to understand what exactly the fixture is, what exactly the yield is, and how both of them are used. Okay. So, let us see the example. So, here I have written one fixture and we have some test cases like test first, test second and test third. Okay. And here what we are doing? Here we are running, means here we have given some print statement. So, here the first test case is getting executed, here second test case is getting executed, here third test case is getting executed. But what we want is before each test we want the database connection. So, before each test this database connection should happen, and after the test executed the database connection should be closed. So, for now let me just comment out this part. Okay, and let us execute. So, here you see the test cases are passed, okay, but before each test we have this established DB connection that is happening, right. Here you see this is happened, then test case passed, this happened, then test case passed, but this one did not execute. Anyway, we have commented it, right. Then how we can close the database connection after each test case execution? So, for that you have to use this yield statement. Okay. So, if you will use yield, after that whatever you will write or whatever code you will write, that will get performed after the test. So, this part is before test, this part is after test, this part is like your connection, this part is your tear down. Okay, let us execute it. See, here this is the test case, right. establish the connection and close the connection, establish the connection, close the connection. So, for each 3 test cases it happened. One more thing also, let us say here I have one, I will put raise exception. So, basically this third test case will fail. So, we will see whether this print statement is getting executed or not. It will get executed. So, that is the power of this yield keyword, right. So, if the test case is getting failed, still the execution will happen, still the tear down things will happen, right. So, let me show you that. See here the third test case got failed, okay. So, this test case got failed, but see still you see this closed DB connection, because after yield whatever you have given, right, whether test case pass or fail, it will get executed. So, the tear down process will happen, okay. So, that will help you to clean up your data basically, okay. So, that is all about your fixture and yield. We will move to the next question. Explain how Python does compile time and runtime code checking. In Python, some amount of code checking is done at compile time, but most of the checking such as type, name, etc. are postponed until code execution or performed at runtime. So, if the Python code references a user defined function that does not exist, the code will compile and run successfully. The Python code will fail only with an exception when the code execution path does not exist. So, that is all about your compile time and runtime execution for Python code. Let us move to the next question. Define module and package. So, Python modules are files containing Python code. This code can either be functions, classes or variables. A Python module is a .py file containing executable code. So, some of the commonly used built-in modules are OS, sys, math, random, datetime, JSON. So, all these are built-in modules. Okay. Then what is Python package? Python packages contains a list of multiple Python modules, and these modules relate to each other and are mainly stored in the same package. When the program needs the external package, the required packages are imported and modules are used by the developers. So, the package is a simply namespace and it contains subpackage inside it. So, examples of packages are like NumPy, Pandas, okay. So, that is all about your module and package in Python. We will move to the next question. What is pickling and unpickling? Pickling is the Python term for serialization process that converts a Python object into a binary representation. Unpickling is the Python term for deserialization process that converts a binary representation back into Python object. So, here you can see if we want to convert a Python objects to a Python file, we can do it through a serialization, and again if we want to revert it, we can do it through deserialization. So, basically your serialization is pickling and deserialization is unpickling. Okay. So, let me show you through a code. So, here if you will see, we have a dictionary object employee, right, which will be serialized. We have a file named as employee.pkl file, right. We have a file employee.pkl file. So, that will store the serialized form of Python object. The pickle.dom function is used to pickle the employee object to the file. It takes 2 arguments, the object to be pickled, that is employee, and then the file object to which the pickled object should be written, that is employee.pkl file. Then you can ask me why we have written this open then WB and all, right. So, we have written this open then employee.pkl then comma WB because we want to open a file, okay. We want to open that file and then write something to it, right. So, basically it should be in the open mode and WB is written, which means write byte mode. So, basically we will open the file and which mode it is in the write byte mode. So, that is what WB means. Similarly, you can also put it into read byte mode. In the read byte mode, you cannot write anything to it, you can only read it. That is why here we want to write something, that is why we have put it as WB. Okay. Then we have unpickled it, here we are unpickling it, right. So, pickle.load function is used to deserialize and unpickle the object from the file. It takes one argument, the file object, from which the object should be loaded. Okay. So, here you can see RB we have written because we want to put it as in a read mode. Okay. So, that is all about your pickling and unpickling in Python. We will move to the next question. What is the difference between shallow and deep copy? So, a shallow copy creates a new object which stores the reference of the original elements. Shallow copy is performed using copy function, which is present in the copy module. So, here in the code if you will see, here we are using this copy, right. So, basically we are using copy function, okay, and where it is present? It is present inside the copy module. Okay. So, a shallow copy does not create a copy of nested objects, instead it just copies the reference of nested objects. What that means? That means a copy process does not recurse or create copies of nested objects itself. So, here if you will see, right, we have one list, okay, then old list, and this list having these values. Then what we are doing? We are creating a new list, okay, and to create the new list, what we are using? You are using this shallow copy method, copy.copy and then old list, then we are printing it. Okay. So, when we are printing this fast to result, if you will see here, right, this is the output. So, it is exactly same, whatever in the old list, in the new list also contains the same thing. Then what we are doing? Then we are just updating this field old list 1 of 1, we are just updating to what? AA. Okay, we are updating the value to AA, and then what we are trying to do? Again we are trying to print. So, again when we are trying to print, what we are seeing? This old list and new list. See, old list the value 1, 2, 3 and 4 AA, because we updated this value, right. So, that we are seeing, but in the new list also we are seeing the same value present. So, basically it just copies the reference of nested objects. We will see how it happens in the deep copy. Okay, let us see. So, what is deep copy first? Deep copy creates a new object and recursively adds the copies of nested objects present in the original elements. Deep copy is performed using deep copy function. So, here you can see we are using deep copy. So, again whatever we have added here, the same thing, only thing is here we have used copy.copy, here we have used copy.deep copy. So, this is your shallow copy, this is your deep copy. Okay. So, deep copy is performed using deep copy function, which is present again in the copy module. Okay. The deep copy creates independent copy of original objects and all its nested objects. Okay. So, that is the main difference, right. So, here if you will see, again we have done the same thing, old list, new list, and we are printing. If you will see in the first, the output remains same for old and new, 1, 2, 3, 4, 5, 6, 7, 8, 9, here also same. Then again we are updating this value to AA, and now we are printing the old list and new list. In the old list, what we are seeing? 1, 2, 3, 4, AA 6, 7, 8, 9, because this value we have updated in the old list, but for the new list, whatever was there previously, we are seeing the same 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So, it is not updating here in the new list, but here if you will see in the shallow copy, it was updating. Okay. It was updating to the this value. Okay. Whatever present in the old list, it was updating to the same. So, that is the major difference between your shallow copy and deep copy. So, in your deep copy, it creates an independent copy of the original object. Okay. It is an independent copy of your original objects and all its nested objects. Okay. So, that is the major difference between shallow copy and deep copy. So, we will move to the next question. Explain inheritance in Python. Does Python support multiple inheritance? So, what is inheritance? So, the method of inheriting the properties of parent class into a child class is known as inheritance. The class from which we are inheriting is called superclass, and the class that is inherited is called your derived class or child class. The main purpose of inheritance is the reusability of code. What that means? We do not have to write the code again and again. We just inherit the properties we need in a child class. So, in inheritance, the child class acquires all the data members, properties, functions from the parent class. Also, a child class can provide its specific implementation to the method of the parent class. So, that is the advantage of your inheritance. Inheritance is transitive in nature. If a child class inherits properties from a parent class, then all other subclass of the child class will also inherit the properties of the parent class. It represents a real world relationship between parent class and child class. For example, you are getting all the properties from your parents. Similarly, your kids, your child will also get the same properties. So, that is the real parent child relationship. Okay. So, we will see what are the different types of inheritance. There are 5 different types of inheritance: single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance and hybrid inheritance. So, what is single inheritance? A child class inherits from a single parent class, that is your single inheritance. A child class inherits from a single parent class. So, here you can see one child class is getting inherited from a single parent class, that is your single inheritance. What is multiple inheritance? Multiple inheritance means one child class can inherit from multiple parent classes. So, here you see one child is getting inherited from 2 parent classes, okay, that is your multiple inheritance. What is multi-level inheritance? A class inherits from a child class or derived class. So, suppose you have 3 classes A, B, C, okay, and A is the super class, B is the child class of A and C is the child class of B. So, here you will see we have one parent class and this child class 1 is getting inherited from the parent class and again child class 2 is getting inherited from child class 1. So, child class 2 is getting inherited from child class 1. So, we can say a chain of classes is called multi-level inheritance. Okay. So, you got the difference, right? What is multiple inheritance? In multiple inheritance, one class is getting inherited from multiple classes, multiple parent classes, but in the multi-level it is like parent class to child class, again child class to his child classes. Okay. Then hierarchical inheritance. So, when more than one child class is derived from a single parent class, okay, that is called your hierarchical inheritance. So, in other words you can say one parent class and multiple child classes. Here you can see one parent class can have multiple child classes, that is your hierarchical inheritance. Then your hybrid inheritance. So, when inheritance is consist of multiple types of combination of different inheritance is called your hybrid inheritance. Okay. So, it is combination of all whatever 4 types of inheritance we saw, right. If it is a combination, then it is hybrid inheritance. Okay. So, here you can see the parent from one parent class 2 child classes are coming, that is nothing but your hierarchical inheritance. Then from 2 child classes again another child is coming, that is your multiple inheritance. So, here in this example what we have seen, the combination of hierarchical inheritance and multiple inheritance. Okay. That is why it is your hybrid inheritance. Okay. So, that is all about your inheritance in Python. Okay. So, we will move to the next question. What is polymorphism in Python? Polymorphism means the ability to take multiple forms. So, for instance, if the parent class has a method named as ABC, then the child class also can have a method with the same name as ABC having its own parameter and variables. In programming, polymorphism refers to a function having the same name, but being used in different ways and different scenarios. This makes programming easier and more intuitive. So, let us understand with this code. So, here we have a parent class named as animal, which has a method named as type. Also, we have a child class named as dog, which is inherited from parent class animal, and type method is also inherited, but again it is redefined as per the child class need, because in the parent class what was the print statement? Print statement was print animal, but in the dog class the print statement is print dog. This thing is called method overriding. So, basically the method name remains same in the child class, but it has been overridden. Then what we are doing? Then we have two objects. Object 1 is instantiated from the parent class and object 2 is instantiated from child class. So, what is the output we are getting here? The output we are getting here is animal and dog. So, the first one object 1 dot type. So, for that we are getting animal, and for second one object 2 dot type we are getting dog. Okay. So, that is one example of polymorphism. So, we will move to the next question. Define encapsulation in Python. The process of wrapping of variables and methods into a single entity, that is class, is known as encapsulation. Encapsulation is a fundamental concept of object oriented programming. It acts as a protective shield that puts restriction on accessing variables and methods directly and can prevent accidental or unauthorized modifications of data. So, if I will give you a real life example. So, encapsulation concept can be a car concept. So, basically the car driver can interact with various features such as steering wheel, pedals, dashboard and all, right. So, these features are accessible to the driver and similar to public variables, but the driver cannot see or interact with many parts of the car such as engine or transmission. So, these parts are like private variables. So, accessible only within the class or object. So, by using this private, protected and public variables in encapsulation, we can control access to an object's data and ensure that it is only modified in a controlled way. So, there are three types of access modifiers. One is private, then public and protected. So, public members are accessible anywhere from the class. All the member variables of the class are by default public. Then protected members are accessible within the class and also available to the subclasses. Then private members are accessible within the class. Okay. So, public is accessible anywhere, protected is accessible in class and also subclass, but private members are accessible within the class. So, that is the major difference between this private, public and protected, and these are the access modifiers. So, if we will see it with an example, right. So, here we have a class named as employee, which has data members as name and age. The class has a function, display function. So, since we do not specify the access specifier type, it is public by default. Here we can see that we are accessing the function using the class method, also accessing it directly from the outside. So, that is overall your encapsulation concept in Python. We will move to the next question. How do you do data abstraction in Python? Data abstraction is one of the most essential concepts of Python OOPS concept, which is used to hide irrelevant details from the user and show the details that are relevant to the users. For example, we see the car from outside, but we did not see the inner parts like the car engine, which means that the outside of the car works as an abstraction. It hides the inner parts of the car. In Python, abstraction can be achieved by using abstract classes and interfaces. A class that consists of one or more abstract method is called abstract class. Abstract methods do not contain their implementation. Abstract classes can be inherited by the subclass and abstract method gets its definition in the subclass. To make the abstract class, an abstract keyword is used. So, Python provides ABC module to use abstraction in the Python program. Here you can see we are using ABC module. Okay. We will move to the next question. What is monkey patching in Python? Monkey patching refers to the dynamic or runtime modification of a class or module. It is an advanced topic in Python. Then why we need this monkey patching? So, while working on a real time project, it might so happen that the third party library is not working well. So, in order to change it from our project end, monkey patching becomes very helpful. So, with monkey patching, we tend to change a particular code at runtime so that it behaves differently. Python being an interpreted language allows us to do runtime modification. We can reopen the class and modify its behavior using monkey patching. So, we will see with an example. So, here we have a class power, then we have a function named as square which returns the square of the input number. Then we are creating an object of the class and using that object we are printing the square function with an input as 3. Then what is the output we are getting? We are getting the output as 9. Now, let us see this piece of the code, right. So, now we have another piece of code in a separate file, and here we have changed the behavior of the square function at runtime. So, we have replaced the defined function square with the newly defined function cube at the runtime itself. So, first we have imported the previously created file. The previous file name was sub0 and this file name is sub1. Okay. So, we have imported the previously created file, that is sub0.py file. So, that is what you can see here, import sub0. Then we have created a function as cube which returns the cube of the input number. Here we are doing the monkey patching. Then we have created the previously defined class object and printing it and seeing the output as square of 3 is 9 and cube of 3 is 27. So, that is how we can do monkey patching. Okay. So, basically the dynamic or runtime modification of a class or module. Okay. So, we will move to the next question. Explain split, sub, subven methods of remodule in Python. To modify the strings, Python's remodule provides 3 methods. One is split. So, basically uses a regex pattern to split a given string into a list. Then sub method. So, basically it finds all substring where the regex pattern matches and then replace them with a different string. Then subven, it is again similar to sub function and also returns a new string along with the number of replacements. Okay. So, thus the overall use of all these 3 methods. We will move to the next question. Name few common Python libraries which you use in your project. So, basically this is a very practical question. So, people just ask this question to understand whether you have really worked on Python and you have used it in your automation. If you have used, then what and all libraries you have used, right. So, here we have a few libraries, for example, Selenium. Selenium is a powerful library for automating web browsers. It is primarily used for testing web applications. Then PyTest. PyTest is a popular testing framework that makes it easy to write simple and scalable test cases. So, if you are automating something using Python, then PyTest is the best choice. Okay. Then Pandas. While Pandas is widely known as data manipulation, it is a fantastic automation tool for data processing and analysis tasks as well. It easily handles large data sets. Udul library simplifies task scheduling and automation. Paramiko is a Python library for remote server automation and secure file transformation through SSH. Playwright, again a very powerful library for browser automation and testing. Request is a popular Python library for making HTTP request. It can be used to test APIs by sending HTTP request to API endpoints and validating the responses. Behave is a Python library for behavior driven development or BDD. NumPy is a fundamental package for scientific computing in Python. Coverage.py, it is a code coverage measurement tool for Python. Faker is a library for generating fake data such as names, address, emails and more. So that's all. Thank you. Thank you so much. Here we have discussed 35 Python interview questions. I hope these questions are very helpful for you. If you like this video, please press the like button, share it with your friends, and do not forget to subscribe. Thank you. Bye bye.